This video is a documentary of the harmful effects of ocean acidification that is primarily caused by the hands of humans. Ocean is a vital part of our planet that sustains and enchants us with its mysterious life forms. Ocean creates endless varieties of species and thus creates a vibrant ecosystem we see today. They protect our coastlines from storms and cleans our shores. The ocean regulates climates to protect the weak and sensitive life forms that exist on Earth. Not only that, ocean is a storage of goods we people can use to feed ourselves and prosper. However, the ocean's power to create life competes with our power to destroy it through our own industrial development and the increase of carbon emission. So what is ocean acidification? When carbon dioxide (CO2) is absorbed by seawater, chemical reactions occur that reduce seawater pH levels and the saturation states of biologically important calcium carbonate minerals. These chemical reactions are called ocean acidification. Calcium carbonate minerals are the building blocks for the skeletons and shells of many marine organisms. In areas where most life now assembles in the ocean, the seawater is supersaturated with calcium carbonate minerals. This means there are abundant building blocks for calcifying organisms to build their skeletons and shells. However, continued ocean acidification is causing many parts of the ocean to become undersaturated with these minerals, which will likely to affect the ability of some organisms to produce and maintain these shells. Since the beginning of the Industrial Revolution, the pH of surface ocean waters has fallen by 0.1 pH units. Since the pH scale is logarithmic, this change represents approximately a 30% increase in acidity. Future predictions indicate that the oceans will continue to absorb carbon dioxide and become even more acidic. Estimates of future carbon dioxide levels, based on usual emission scenarios from factories, indicate that by the end of this century, the surface waters of the ocean could be nearly 150% more acidic, resulting in a pH that the oceans haven't experienced for more than 20 million years. Here's a little pop quiz. Ocean acidification is caused by A. Global warming, B. Climate change, C. Increasing carbon dioxide emissions, D. Increasing methane emissions, and E. Stormwater pollution. Pick your choice. Yes, the answer would be C. Increasing carbon dioxide emissions. Here's another one. A pH of 7 is blank than a pH of 8. A. 12% less acidic. B. The same acidity. C. 12% more acidic. D. Twice as acidic. And E. 10 times as acidic. Yes, the answer would be E. 10 times as acidic, since we know that pH scales are logarithmic. Moving on to the next topic of ocean acidification, the biological impacts. Ocean acidification is expected to impact ocean species to varying degrees. Photosynthetic algae and seagrasses may benefit from higher CO2 conditions in the ocean, as they require CO2 to live just like plants on land. On the other hand, studies have shown that a more acidic environment has a dramatic effect on some calcifying species, including oysters, clams, sea urchins, shallow water corals, deep sea corals, and numerous planktons. When shelled organisms are at risk, the entire food web may also be at risk. Today, more than 1 billion people worldwide rely on food from the ocean as their primary source of protein. Many jobs and economies in the US and around the world depend on the fish and shellfish in our oceans. In recent years, there have been a near total failures of developing oysters in both aquaculture facilities and natural ecosystems on the West Coast. These larval oyster failures appear to be correlated with naturally occurring upwelling events that bring low pH waters undersaturated in water quality changes to near water environments. Lower pH values occur naturally on the west coast during upwelling events, but recent observations indicate that CO2 is contributing to seasonal undersaturation. Low pH may be a factor in the current oyster reproductive failure. However, more research is needed to unscramble potential acidification effects from other risk factors, such as freshwater inflow, pathogen increases, or low dissolved oxygen. Therefore, it is premature to conclude that the acidification is responsible for the recent oyster failures. But acidification is a potential factor in the current crisis to this over $100 million a year industry, which prompts new collaborations and accelerates research on ocean acidification and potential biological impacts. Not only shellfishes, but corals are also at risk. Many marine organisms that produce calcium carbonate shells or skeletons are negatively impacted by increasing CO2 levels and decreasing pH in seawater. For example, increasing ocean acidification has been shown to significantly reduce the ability of reef-building corals to produce their skeletons. In a recent scientific paper, coral biologists reported that ocean acidification can compromise the successful fertilization, larval settlement, and survivorship of elkhorn coral, an endangered species. These research results suggest that the ocean's acidification could severely impact the ability of coral reefs to recover from disturbance. Other research indicates that by the end of this century, coral reefs may erode faster than they can be rebuilt. This could compromise the long-term viability of these ecosystems and perhaps impact the estimated 1 million species that depend on coral reef habitat. Ocean acidification is an emerging global problem. Over the last decade, there has been much focus in the ocean science community on studying the potential impacts of ocean acidification. Since sustained efforts to monitor ocean acidification worldwide are only beginning, it is currently impossible to predict exactly how ocean acidification impacts will cascade throughout the marine food chain and affect overall structure of marine ecosystems. With the pace of ocean acidification accelerating, scientists, resource managers, and policymakers recognize the urgent need to strengthen the science as a base for sound decision-making and action. Here's another pop quiz. How are coral reefs affected by ocean acidification? Here are some examples. Less carbonate availability in seawater, corals grow slower, lower rate of calcification. 2. Here's another pop quiz. Name one other organisms, besides coral, that directly affects by ocean acidification. Some of the examples are oysters, tetrapods, mussels, clams, and crabs. Ocean acidification will have a drastic effect on shell organisms and on coral reefs, but what about its effect on humans? Many people mistakenly believe that the oceans may be turning to acid and that it will no longer be safe for humans to enter into the water. This is not true. Even in the most extreme scenarios for the next century, an ocean pH of 7.8 is not directly harmful to humans. In fact, many swimming pools maintenance guides suggest that people keep their pool pH between 7.2 and 7.8. So why would ocean acidification be detrimental to human health? The previous two lessons were focused on the marine food chain and on the coral reef ecosystem. Humans are inextricably linked to the health of the ocean. We have always relied on the ocean's resources for food, recreation, transportation, and medicines. From an interpretive standpoint, the important thing is to help people realize how they are personally connected to the ocean, and then to be able to explain to them how that connection is being jeopardized by ocean acidification. One of the most obvious connections people have with the ocean is seafood. Most of the shellfish we eat are going to be negatively impacted by ocean acidification due to the fact that they will be unable to build sturdy shells. Some oyster hatcheries in the Pacific Northwest have already been impacted and have seen declines in larval settlement and survival rates. Petropods may seem insignificant to many people, but since they are a major food source for fish, their survival is very important to us. I hope this documentary delivers a new perspective on the severity of the issue of ocean acidification.
Thank you.